Okay, we have here today a really good problem from the UNSW CPMS integration bee from 2023. This was finals number 3. We have the integral of cosine x to the 1010 over sine x times the square root of sine x to the 2022 minus cosine x to the 2022 dx. Okay, now to get started with this, I just noticed that we have a whole bunch of sines and cosines in this expression. In a lot of cases, what we want to do with this is multiply by secant squared x to clean this thing up, right? But this trick only really seems to work when we have smaller exponents here, where we have like 1010 and 2022. This is not quite going to do it. But what I thought to do first when I was working on this on paper was, instead of multiplying by secant squared x, what if I multiplied by secant to the 1010x? Well, when you do that, secant's 1 over cosine. You multiply this in, the secant to the 1010 cancels with this cosine of the 1010. We end up with 1 in the numerator. When I multiplied this into the denominator, I ended up getting like a tangent here, but it was pretty messy. But then what I realized is we're creating like a tangent somewhere here in the denominator. Well, then we could do a u substitution if we had secant squared in the numerator. So in order to get a secant squared, I don't need 1010 here. What I'm going to need is I'm going to need this here to be 1012. And then I'll change this to 1012. So let's just multiply this all out pretty carefully so we can see what's happening. So what I'm going to do is we have our cosine 1010x here. I can split up this secant 1012. I can write it as secant 1010x times secant squared x. That way, this is going to cancel with this here. But now what I want to do with this secant 1012x multiplying into the denominator, we want to do this. I'm just going to rewrite secant as 1 over cosine. So we're going to have 1 over cosine to the 1012x. But what I want to do is I want to take one of those cosines over here so we can create this as tangent. Okay, so we only have, let's change this to a 1011. But then I'm going to want to take this cosine x to the 1011 and bring it inside this square root. So what I'm going to do is I'm going to write this, I can rewrite this as the square root of cosine x to the 1011, but inside the square root I just need to square it. So then this here is actually going to turn into cosine x to the 2022, which sets me up to divide it in here. So I'll rewrite this just to clean it all up. So we're going to have, in our numerator, we're going to have secant squared x dx here. This right here is just tangent. And then let's divide this cosine x to the 2022 into the square root. So doing this, on this first term, cosine x to the 2022 divided into sine 2022x, this is going to give me tangent of 2022x minus, this here is actually the same as this, so these are essentially going to cancel over here, and we're just going to be left with a 1. But now we're in good shape to do that u substitution I mentioned originally. We have tangent here in 2 places in the denominator, and we've got the derivative of tangent right here. So what I want to do for my u substitution, we'll come over here. For u, we're going to say u equals tan of x, and du is going to be secant squared x dx. But now I can just go ahead and substitute. So again, the whole numerator is going to be just our du. Then this here is going to be u. We're going to have u times the square root of u to the 2022 minus 1. But now for this integral here, it looks like we could do a trig substitution, but I think what I need to do is simplify it because we can't really do a trig substitution. We don't really want the power to be 2022 right here. So what I'm going to do for my substitution, I guess we'll use t over here. And I'm going to make my t is going to be, I'm going to use all this. I'm going to say t, I'm going to set t equal to square root of u 2022 minus 1. Then before we get a derivative, let's square both sides. So we'll get t squared equal to u 2022 minus 1. I'll take my derivative. So we're going to end up with here with derivative of this is going to be 2t dt. Then we'll take a derivative here with power rule, and this is going to become 2022 u 2021 du. But I think what I'll do is solve for dt, so I can divide by 2t on both sides. Cancel here. We'll have our 2. But for t, I'm going to plug in this expression we have here. So I'll write this as square root of u 2022 minus 1. But then I can just clean this up a little bit, cancel 2 with 2022 and write this as 1011. So we're going to have this expression for dt 1011 u 2021 du over the square root u 2022 minus 1. So now coming back to our integral, we already have kind of part of this. We have this right here. This is the same thing we have right here. So we have part of our dt value. To set it up, I'm just going to multiply on this other stuff. So we're going to multiply in 1011. But I don't want to change it, so we'll divide by 1011 here. And then I also want to force this u 2021 to happen here. We'll multiply in u 2021, but again, I don't want to change it, so we'll multiply it into the denominator as well. So here we're just multiplying by 1. So now all this stuff, everything basically, that's all our dt values. So now we'll go ahead with this substitution. And when we do this, we have this 1 over 1011 in front. And then like I said, everything here is just dt. So we'll put dt in the numerator. And then here we have, this here is going to become u to the 2022. But I can get a value for that real easy over here because I can just solve for u 2022. So u to the 2022, just adding 1 on both sides is going to be the same thing as t squared plus 1. So since that's all we have in the denominator, our whole denominator just becomes t squared plus 1. But now we're in good shape. This integral is just arctan. So what I can do is come down here, integrating. We're going to have 1 over 1011 arctan of t. So now we just need to back substitute in order to finish this off. So for my final solution of this, what we'll do is we'll just put the 1011 in the denominator. We're going to have arctan of this t, but we'll back substitute with the square root of u. But u, we'll do this all in one step. U is going to be tan x. So we're going to have here tan x to the 2022 minus 1, add a plus c, and that's it. Okay, so there it is. Really good problem from UNSW CPMS 2023. Thanks everyone for watching. Have a good day.